Okay, so let's now apply linear regression using that equation to a practical example. So as I mentioned on the first video, this is our general equation for a linear regression of one predictor, y equals a plus bx, a being the intercept, that is where the equation or the linear, in this case, hits the y-axis, and then b the slope. So we're going to calculate that, put this together, and predict an outcome based on this example. You can see on my y-axis here I have hypothetical, of course, ice cream sales by week, and then on my x-axis temperature in Celsius. My linear already starting at 200, that's my intercept. So I'm going to write it down here. So we're going to start with 200. I don't know the slope yet. And then whatever number we want to investigate will be our x. So how do we go about calculating that slope? If you recall from high school, we can calculate the slope or the area of this triangle by simply raised over run. So that will be the difference between, I just used two trajectories there, this green lines, you can pick anywhere. I use this one here, start at 550 and then 350. So that's here my y2, and this is here, it's my y1, the highest and the lowest. And then similarly, I did the same on the x. I'd see, you can see where the points intersect. So about 31 here, not exact, so that's my x2, and then about 14 x1. So if I actually take those differences, on the rise would be 500 minus 550 minus 350 divided by 31 minus 14, again approximately. Okay, so that would be, I believe it's 200 over 17. So my slope coefficient in this case will be, what is that? Let me use my calculator here. 200 divided by 17, 11.76. So now I have my b, and if I plug that number into my equation here, so say 200 plus 11.76 times, let's say you want to predict the sales based on 35 degrees Celsius, so 35. And then we're going to eyeball it on the graph and see if it makes sense. So that will be 200, which is my intercept, plus 11.17, 76 times 35, 411, 76. So the y in this case here will be that, plus 200, 611, 76. So what we're saying here is that for a prediction of ice cream sales based on 35 degrees out of this model, if I eyeball it here, 35, really eyeballing, not a perfect line, 611, so it's a little, again, this is not a perfect graphic, but just about there. So that will be my prediction on ice cream sales based on that 35 degrees. So that's how you apply the equation, that's how we use it for prediction of y or response values based on your x independent values. A little more in the next video. See you next time.